Hey everyone, this is AI Labs, and I'm going to be testing out the Phi-4 model by implementing changes on a Spotify clone that I'm currently working on for fun. Let's see if it'll succeed in the tasks or not. Phi-4 has officially launched, with Microsoft releasing the model weights under an MIT license, making it commercially usable. At just 14 billion parameters, it delivers remarkable performance, scoring 84.8 on MMLU and 82.6 on HumanEval for coding, which sets a new standard for models of this size. It's highly efficient, capable of running locally at reasonable speeds, and performs exceptionally well across various tasks, including coding and reasoning. While I don't usually rely on benchmarks alone, let's explore its real-world performance ourselves. So, this is the Spotify clone I'm working on right now, focusing solely on the front end for now. I'll be using the Phi-4 model to see if it can modify this specific component, the playlist card component, and integrate it into my existing Spotify clone. Let's see how it performs. Okay, so if you want to install the Phi-4 model locally, what you can do is go ahead and install OLAMA. First, open your browser, search for OLAMA, and visit the site. Then, go to the download section and select the version for your operating system, whether it's macOS, Linux, or Windows. Download and install it and make sure it's up and running. After that, go to the model section where you'll find the different models that OLAMA offers. You should see the Phi-4 model listed. Click on the model and here you'll find the command for installing and running the Phi-4 model. Simply copy this command, then open up your terminal. After copying the install command, make sure OLAMA is running, then paste the command into your terminal. If you haven't installed it yet, the model will be downloaded, which is about 9 gigabytes. Once it's done, you'll be able to run the model. If you've already downloaded the model like I have, this command will start the model. If you've already installed it, you can ensure it's working by sending a message and you'll see that it will respond to you. If you're unable to run it locally on your own system, you can go ahead and search for OpenRouter and open the site. Here, you can obtain keys for LLMs if you're unable to run them locally. The Phi-4 model is currently in the training section, but if it's not, you can go ahead and search for the model here. Once you find it, open the model, go to the API section, and create your API key. You can name your API key whatever you like, and you can also set a credit limit for it. Then, copy the API key and make sure to store it in a safe place, as you won't be able to access it again once you lose it. If that happens, you'll have to delete it and create a new API key. Now, I'm going to show you how to install Bolt.diy. If you already know, just skip ahead to the testing part. To install Bolt.diy, go to the GitHub page, copy the URL to your clipboard, and scroll down to find the installation instructions. Next, open a terminal window and run the command. After cloning it, go into the directory and then use npm install to install all the dependencies. Once that's done, run npm run dev to start the network server and launch the application. You can then click on the provided link to open it in your browser. So, what I'm going to do right now is use a screenshot of the card component from my Spotify clone and provide it as a prompt. We're working on a React card component using TypeScript and Tailwind CSS, highlighting artist and song details. When you hover, a menu slides out with the artist's bio, song info, and options like play song or add to favorites, all styled with a frosted glass effect. Smooth animations make the design feel interactive and modern. Let's see how it performs. The generation has started and it's currently installing npm and setting up the project so I can preview the card component it creates. However, we encountered a terminal error. I asked Bolt to analyze the error, and it provided suggestions but didn't apply them. I then asked it to apply the changes as well. Unfortunately, it still didn't apply the changes, so I tried implementing the suggested fixes myself, but the issue remained unresolved. Ultimately, this model was unable to generate a simple TypeScript card component. Instead of using Bolt.diy with Phi-4, I used Claude to generate the card component. I provided the screenshot along with the same prompt, and this is the code it generated. Here's the preview. We have the artist's name and the featured song, along with the respective pop-ups. Now what we're going to do is open up Cline and test whether Phi-4 can integrate this new card component into the existing Next.js 14 app. Now, I'm going to show you how to install Cline. If you already know, just skip ahead to the testing part. To install it, open VS Code, as Cline is an extension. Go to the extensions bar and search for Cline. You'll find Cline, which was previously named Claude Dev. Just open it up and go ahead and install it. I have imported the Spotify clone I was building into VS Code so I can use the Phi-4 model in Cline. First of all, as you know, we use the OpenRouter API with Bolt.diy due to an issue with Bolt.diy. But since Cline can use the OLAMA model running locally on my device, here's what you need to do. Open Cline, go to the settings panel, and under API provider, select OLAMA. The base URL is set to the default one, which is correct. But if you've changed it, enter your custom URL. If you have multiple models installed, their names will be listed. Since I only have Phi-4 installed right now, I'll go ahead and select it. Now, I can run Cline with Phi-4. I have copied the revised card component code that I generated from Claude. What I'm going to do now is open the card component. This playlist header here is the component I want to change. I'll go into Cline, where I've already configured the settings to be used. Next, I'll open a new window, paste the prompt I got from Claude, and ask it to integrate this into my existing Spotify clone app. I also wanted to avoid creating a new file, so let's see how it performs. I've sent the request and it's working now, so let's see if it integrates the code correctly. At the moment, it's asking me how to proceed with the task. I had clearly stated that it needs to integrate the code I provided into the playlist header, yet it's still asking what I would like to do with the playlist header. So I'll clarify again and tell it to modify it. Oops, I accidentally sent the code without the instruction. Let me try again. I've prompted it again, so let's see if it understands my request and actually updates the cards. It's still facing the same issue and doesn't seem to understand my request. I tried specifying the file using the appropriate syntax, but the tool still failed to identify the task. It repeatedly responded that it didn't understand what needed to be done. Even after explicitly instructing it to make modifications, it was unable to comprehend the required changes. In my opinion, this issue stems from the extremely small context window of the AI model, which limits its ability to understand the task effectively. Since I couldn't generate the Spotify clone I initially wanted and planned, I decided to test the tool by creating a smaller app instead. So, I'll go ahead and ask Bolt.diy to make a playable synth keyboard. You can see that it has started up and is installing simple dependencies. The preview has loaded, but nothing is visible yet. Now the keyboard has appeared. Let's see if it works. It managed to create the keyboard, but there's no sound coming out. I prompted Bolt.diy again, and since it was a small change, it was able to fix the issue easily. As you can see, the keyboard is now playable. However, due to its very small context window, it struggles with handling more complex tasks. After testing it, it seems that while the Phi-4 model performs well in many areas, the benchmarks didn't fully reflect its performance in real-world coding tasks. It runs smoothly and efficiently on local devices, but when it came to more complex tasks, it didn't quite meet expectations. So while it might not be the best choice for coding-heavy projects, it could still be useful for other types of tasks. Before we dive in, make sure to hit that subscribe button. It really helps us out and ensures you won't miss any of the cool tools and tips we've got coming your way.